Hi everyone. In this video, we'll review a few concepts relating to limits that we're going to need for the next few topics. To motivate the idea of why we're going to need limits, you can consider this thought experiment. In the past, we've considered lots of integrals from a to b, but is it possible to integrate from a all the way up to infinity? Well, we know it's never possible to actually reach infinity. So anytime we want to think about something like this, what we can do instead is approach infinity using limits. So this suggests the following interpretation of this integral. Instead of integrating from a to infinity, we instead integrate from a to t, with the understanding that t represents a really large number. The larger the value of t, the closer it is to infinity. If we took the limit as t approaches infinity, this would have the effect of making t larger and larger, which is what we really want. So what you see here is the definition of how we would interpret an integral from a to infinity. And we'll get more into details about that later, but for the moment, let's just remind ourselves of some more basic concepts relating to limits. So let's say you were asked to calculate the limit of this fraction. So we would like to know what value is this fraction approaching when x gets closer to 2. To figure that out, we typically just replace x by 2 and see what happens. In this case, you can pause and check that after simplifying, we're left with a result of 0 over 0. What a lot of students do wrong at this stage is they say, well, we can't divide by 0, so this is undefined. Again, that is wrong, because when we take a limit, it's important to understand that the 2 we plugged in wasn't actually 2. It was representative of a number which is getting closer to 2. And that means our denominator doesn't actually have a value of 0, it's just getting closer to 0. The correct word to describe this result is indeterminate. And that's because 0 over 0 is kind of a meaningless result. It doesn't really tell us what specific value the limit has, if any. More generally, a limit is called indeterminate if its value cannot be determined without additional information. In other words, the limit might have a value, we just don't know yet. As a caution, indeterminate does not mean the same thing as undefined. I find students often incorrectly use these words interchangeably, so let's make sure we're aware of the difference between these. An undefined limit is one that doesn't have a value, or to say it another way, the value doesn't exist. By contrast, an indeterminate limit might have a value that exists, but we just don't know yet until we uncover some more information. So as you can see, this is an important distinction, so make sure to use the terminology appropriately. There's of course the question of how to get the additional information when we have an indeterminate limit, but generally speaking, it can be helpful to simplify. Normally that means canceling something out, either by factoring or rationalizing. Going back to the indeterminate limit we've been given, we notice a simplification could be made by factoring the denominator. Now, the factors look similar to the numerator, and in fact, if we factor out a negative, the denominator factors look exactly the same as the numerator. So this allows us to make a cancellation. And after that, we can try evaluating this limit one more time. So replace x by 2 and see what happens. This time we get a result of minus 1 over 0. And this is no longer indeterminate because, think about it. We know what happens when we divide negative 1 by a number which is close to 0. Imagine dividing by 0.0001, for example. You'll end up with a really large result. In general, we know that the closer a number is to 0, the larger a result we'll get when we divide by that number. And that means the result is approaching infinity, or perhaps negative infinity, depending on whether the number we divided by was positive or negative. But which is it in this case? All we know is that we're dividing by a number that's close to 0, and that could be positive or negative. So we need to examine the denominator more carefully before we can declare the result as positive or negative infinity. All right, so let's ask ourselves whether this denominator represents a positive or a negative number. For future reference, I'll represent a positive number close to 0 using this notation of 0 with a plus sign. That just indicates a value which is slightly greater than 0. And similarly, a value slightly less than 0 will be indicated by 0 with a minus sign. You'll notice that whether or not our denominator is positive or negative actually depends on which side we approach from. If we consider the limit as x approaches 2 from the right, then x is a number which is larger than 2. So in our denominator, we see that 2 is being subtracted from a number which is larger than 2, and the result will be a positive value which is close to 0. We can now see this fraction as negative over positive, which provides a negative outcome. And so negative infinity is the result when we approach 2 from the right. But what about if we approach 2 from the left? In this case, x would be a number which is less than 2. So in our denominator, we see that 2 is being subtracted from a number which is less than 2, and the result will be a negative value which is close to 0. We can now see this fraction as negative over negative, which provides a positive outcome. So we now know the value of the one-sided limits. But at the end of the day, what we were asked for is the value of this two-sided limit. Notice the one-sided limits are not equal, and when that happens, we declare that the two-sided limit does not exist, or DNE for short. So as it turns out, our indeterminate limit turned out to also be undefined, but it did take all this additional information to demonstrate that properly. It turns out 0 over 0 isn't the only type of limit that we consider as indeterminate, so let's make sure we're aware of all the other possibilities. Other indeterminate limits include infinity over infinity, 0 times infinity, infinity minus infinity, 0 to the power of 0, 1 to the power of infinity, and finally, infinity to the power of 0. Whenever you see a limit of any of these forms, it means that more information is needed before you can make a conclusion. So I suggest memorizing these so that you can recognize them in the future, or at least consider putting them on your formula sheet. Now, I wouldn't blame you if you didn't completely understand why some of these are considered indeterminate, so let's talk about that quickly. In general, the reason is because you'll notice that all these types have two components in them. And each of those components lead us to conflicting interpretations. Let me show you what I mean by that. Consider the 0 over 0 form, for example. We have two components, a 0 in the numerator and a 0 in the denominator. The 0 in the numerator suggests that the value of the limit should be small. After all, if we're already close to 0 and then we divide, the result should remain close to 0. On the other hand, if the number we divide by is also close to 0, that suggests we should get a large result. But the limit can't be both small and big. So due to this conflict, we can't make any meaningful interpretation of this. What about 1 to the infinity? You might think 1 to the power of anything should just be 1, so why is this indeterminate? It's important to keep in mind that within the context of a limit, this 1 isn't really a 1. It's a number which is getting close to 1. Let's think about that carefully. If we took a number that's slightly less than 1 and raised it to a large power, we would get a small result. But if we took a number that's slightly bigger than 1 and raised it to a large power, we would get a big result. The limit can't be both small and big, and so again, no meaningful interpretation can be made without some additional information about the nature of this number which is close to 1. All the other indeterminate forms can be explained in a similar way, so I'll leave it to you to think about those ones. I'll wrap things up here, but from this video, make sure you're aware of all the different types of indeterminate forms I just mentioned, as well as what indeterminate means, how it differs from the word undefined, and also basic methods relating to calculating limits such as factoring and rationalizing. So I'll see you next time.